Welcome, everyone. My name is Amit. I'm a software engineer at Uber, and today we're going to talk about testing in production, how testing in production could be a viable solution for your company, why we choose to do testing in production, and maybe take some of the scare away from this term of testing in production. So let's jump right in. So meet Alice. Alice is a software engineer developer at a company. She owns a service called A, and she writes software which is deployed in service A. Service A gets requests from service B and C. They talk to the endpoints of A, and we can call those upstream services. In turn, Alice's service talks to three other services. We can call them downstream services. So this is typical setup for a software developer in a microservice architecture. So let's say one day Alice makes a change, A prime, to her service. Now it's not deployed yet. She just wants to make sure her service works correctly, both upstream as well as downstream. Now, upstream more than downstream more than upstream is an interesting problem, because to make sure that services D, E, and F work correctly with A, in other words, the integration testing of A is an interesting problem, because there are multiple ways we can go about that. So let's say Alice sets up a test runner which is able to talk to endpoints that she wants to test, and now Alice has an option. She can either spin up different test instances of D, E, and F in a separate environment. We can call that as a parallel stack. And this applies transitively to all the services downstream of D, E, and F. So we're talking about setting up a parallel stack altogether, and she can have A prime talk to D prime, E prime, F prime, so on, and transitively to the other nodes in this graph. Other option is A prime can talk directly to D, E, and F. Now, this is what we call testing in production, where services D, E, and F, and transitively all the services downstream of those are handling both test as well as production traffic at the same time. And this is what we're going to talk about, in what situations it makes sense, and what are the design considerations you need to take into account in order to come up with a framework that supports this kind of system. Key takeaway for this talk, I'm putting this up front, is that testing in production can be a viable solution, and that's primarily what this talk is about. Let's look at the agenda. So we'll go through some of the scale aspect of the problem that we're facing, why test in production, some philosophy behind that, tenancy-oriented architecture, why tenancy becomes an important aspect of this problem. We'll look at some design considerations there, and we'll dive deep into building blocks and talk a little more in detail about the architecture. Also, we'll talk about how this architecture can be extended to other applications. The scale. So this is the scale that Uber operates on, about 600 cities, 64 countries, 75 million active riders and 3 million active drivers. We see about 15 million trips per day, and cumulatively we have seen so far 10 billion trips. So this is the scale we need to work with, and what drives this is a mesh of microservice architecture. Each dot that you see here is a microservice, and the radius of the dot represents the QPS or the RPS of that service. The links between the dots are the messages going back and forth between the services. We're talking about thousands of microservices, and these microservices are owned by multiple teams. Some services are owned by some teams jointly, and effectively we see thousands of commits per day over all the services that we have. So why test in production? So this is effectively a comparison between a parallel stack, where you have every service running in a parallel stack versus testing in production where part of the test traffic is flowing into production as well. One of the benefits of not having a parallel stack is that operational cost is less. In order to have a parallel stack, you need to think about what is the capacity for that stack. And you could be talking about multiple stacks depending on what kind of environments that you want to test this in. And so every service owner needs to think about what's the capacity they want to provision in each of the stack. And there might be synchronization needed both in terms of code, config, and data. Another aspect that we need to think about is end-to-end capacity planning. Let's say you want to make sure your microservice architecture is able to handle X amount of load. And typically how you do is you have there are two options. If you have a parallel stack, you could effectively put you could put the entire X as the test load in there. But if you test in production, you put the delta test traffic on the production stack, and that makes it more accurate in the sense that you are actually making sure the same stack is able to handle X amount of load versus some other parallel stack that you just set up. There might be operational differences between the two, and that makes it less accurate. So this is one of the premise why we test in production. And as a bonus reason why we test in production is because it enables other use cases. Same framework that we put in, and we'll talk more about that. Same framework that we put in for testing in production actually enables us to other use cases, and this makes one of the compelling reasons why testing in production makes sense. So let's talk about tenancy-oriented architecture. So the moment we talk about testing in production, we need to think about how do we make different tenants coexist. And here in this case, we have testing and production as tenants. And in an idealized world, what we want is our service, which is represented in the orange box here, is able to understand the tenancy of the tenancy, and it is able to make sure that tenancy is getting propagated to all the different infrastructure pieces that it's talking to, whether it's database, whether it's message queue, caching, logs and metrics, and so on. So we want to build end-to-end isolation between the tenancies here in the case test and production. Also, we want tenancy-based access control in the sense we want to make sure that test is not able to create or mutate production artifacts, and we also want minimum deviation between the two environments. So we will be using the same stack for production, and it makes a lot of sense that it's taking the same code path both for test as well as production traffic to make the tests and capacity planning effective. So what are some of the design considerations when we set out to build this? One of the important thing we need to take into account is different number of infra components that you need to make tenancy aware. For example, if you have 3 different kinds of storage, 2 different kinds of message queues, centralized caching solutions, logging metrics, and so on. So all of these need to be natively aware of tenancy. That's one axis. And you could see explosion to this axis as you put in the number of encodings or transports that your services support, different languages they are in. And one other thing you might want to consider is how do you make this language and transport agnostic to not let the matrix explode. Other aspect is switch between current architecture and the architecture that we want to get to. This is multi-tenant testing in production ready architecture is not going to happen overnight. So all the infrastructure work needs to happen. Also, all the services, they need to possibly make some changes to the way they work. And so this is going to be a gradual transition from the current architecture to the goal architecture. And we need to plan for that. So there'll be a phase when both kinds of systems coexist, and we need to make sure they play along well. So as we define these different environments to make sure this gradual transition is smooth, we might need to worry about tenancy-based service discovery and routing to make sure the traffic is getting routed correctly. And final thing is, we want to minimize the impact on developers and minimize the code changes or the config changes required. So let's talk about the building blocks of tenancy. So first and foremost is attaching a tenancy context to every piece of data, whether it's in flight or at rest. And we'll talk more about each of these things. And how do we propagate this tenancy context through the life of that artifact? Second is tenancy-aware infrastructure. How do we build that? How do we make tenancy? How do we make our infrastructure like storage, message queues, logs, and metrics aware of tenancy? Different environments that we might to standardize and define, and tenancy-aware routing. So context and context propagation. We need to attach tenancy context to both in-flight data, which means things like requests which are flowing from edge gateway to leaf node of your graph, and the data at rest. Anything that, as part of the business logic, service creates, mutates, can be defined, classified as persistent artifact, and we need to attach tenancy context to that. Tenancy in this case can be testing in production, and I'm keeping it open to allow for other use cases to use this framework. And mostly tenancy aligns well with the actors involved, like any test users that are being used in this particular traffic scenario. Other thing that so this tenancy context gets propagated through a transport and protocol agnostic manner. We use an open source project called Jaeger, which allows us to do distributed context propagation. And persistent artifact tenancy implementation depends on what infrastructure we are talking about, whether it's storage, what kind of storage, and whether it's Kafka, message queue, and so on. And we'll talk a little bit more about that. And this slide talks about that. So type of infrastructure components that we're looking at storage, message queues, external caching like Redis, any search component that you might have, and observability, logging, and metrics. So if overall, there are two ways you can think about implementing tenancy or making the infrastructure component aware of tenancy. One is client libraries, which are integrated very close to the application. That does mean that those libraries are language specific. So if you were to implement infrastructure tenancy support in the client library, we'll have to think about implementing that in all the different languages that you support. Other easier approach might be gateway integration. If there is a gateway for a server, for an infrastructure component, you might want to think of implementing it there to make it agnostic to the language. And we take the latter approach. So, like I mentioned, we want to get to a state where everything is testing in production ready. And we call that as a mixed tenancy, where every service instance is able to handle both test traffic as well as production traffic. And what service does here, represented in the light pink box here, that service is in production. It understands tenancy in the sense it takes the context from the request and passes it down with every operation that it does, whether it's talking to any service downstream or whether it's talking to any infrastructure component. So it takes the context which is in the request header and passes down to the client libraries, which in turn take care of the routing correctly to the data store or to the correct Kafka topic, for example. And all the services in here are multi-tenant. They understand both tenancy, test, and production. On the right, on the left-hand side, you have this red box, which is a pre-prod environment, and downstream of that, it's going to all the services which are in production. And this is the goal state that we want to get to. And Since we will gradually build our infrastructure to understand tenancy, we want to make sure that stepping stone is available for services to adopt test tenancy without having infrastructure support. Typically, companies have various different kinds of storage and infrastructure components, and getting them on board to understand tenancy is an upward battle. So this state exists to make sure that if you have an end-to-end flow, that you want to make sure it is test tenancy ready and testing in production ready. This step allows us to manually isolate the testing and production infrastructure artifacts by, for example, configuration. So defining a separate environment which handles only test traffic is one way of doing it, where test traffic is getting routed from the green box to the blue box, and blue arrows represent test traffic, whereas green arrows represent production traffic. And so blue service here, for example, is meant to only handle test traffic. And this is different from the staging environment where developers might stage their experimental code. This is not experimental code. This is production code deployed in a separate environment to handle just the test traffic. So tenancy-aware routing comes into play because we have these different environments, and we want to make sure request gets routed correctly to the correct environment. Since we have these two modes, mixed tenancy mode and test tenancy mode, there will be a world where both kind of services exist. We want to get to eventually mixed tenancy mode, but there will be a world where both kinds of modes would exist, and router needs to be able to route correctly based on the mode of a service. So in this example, and it's a little bit hard to see, but orange boxes are mixed tenancies. Green boxes are production tenancies, means they handle only production traffic. Blue boxes are test tenancy, means they handle only test traffic. So orange boxes take both kinds of traffic, green boxes take only production traffic, and blue boxes take only test traffic. And remember, test tenancy instances are solely designed for handling test traffic. These are not this is not development code. This is production code. If there is any pre-prod or development code that needs to run in the services staging environment, and that in turn can use any of the services downstream. But test tenancy mode is meant only for handling test traffic. So this router that we implemented it out of the box, out of the process sidecar as a sidecar in order to make it language agnostic and transport agnostic. And having ability to route based on the tenancy of a request opens up a lot of different avenues. One of them is instant kill switch. For example, if you want to stop test traffic altogether running through the system, we can do that using this router. So what are some of the extensions to this architecture? Having ability to route based on the request tenancy opens up different avenues. Things like you can do QoS policies based on the tenancy. And here I'm keeping tenancy as an open namespace where it could be testing, production, or anything else. And so tenancy-based QoS is one policy that you could implement, and you could certainly make sure that you have rate limiting for test traffic to safeguard production. Shadow traffic is another use case where you can take part of the traffic and shadow it to a different environment where that environment is meant for doing things like A/B testing. Canary deployment, blue-green deployment is another use case where the tenancy router that we talked about is able to route traffic and in a gradual and incremental deployment fashion to to implement things like canary and blue greens. Record and replay is another thing that I wanted to throw in there. There's something that this router can capture and send it to another service to do offline processing and make those streams available for testing at a later point. So, so these are some of the extensions, and this is the final thought I want to leave you folks with, that testing in production is not as scary as it sounds. With right checks in place, this could be a viable solution. And looking at the extension that it has to provide, it could be a long-term investment in building those building those new features on top of this. Yep, that's it. Thank you.